Okay, looks like we're up and running. Been my experience that students oftentimes have a little difficulty with a cowlick. There, no, with understanding what radian measurements are. Um, Many times, some of my best students, after a couple of months of working with trig, all of a sudden go, "Oh, I get it now." All right, so I think it's important that with many math concepts that you got to start something. You got to start the conversation and you got to continue to have the conversation and allow students the opportunity to process and take time. I know that certainly was my experience understanding radians. I don't know if my explanation will get to the point, but got to try. So I used Desmos to trace a circle. And what we're going to do in this video is approximate the sine of 1, the sine of 2, the sine of 3, the sine of 4, sine of 5, the sine of 6. And I'll have a very brief, well, while we're on that topic, if you don't have an idea of what the question is being asked or what calculation you're being asked to perform, I think that actually states it better. Pretty hard to answer it. If you don't know what's being asked, pretty hard to answer a question. All right, so that's what this video is about, getting a better understanding of what's being asked. I'm sure that, if I have this conversation repetitively, hopefully the explanation will get better. But it's the first time I've tried to do this particular video. So we'll have at it. We'll make sure that some folks who haven't had much introduction to trig at least get a 2-minute conversation over here about triangles and angles. And then we'll take some guesses. I did earlier. I put my guesses over on the wall. And then I actually performed these on Google and just typed it in and got the actual answers to a good degree of accuracy. So let's continue down our way here. And let's make sure that just a 2-minute conversation here. All right, so triangles have sides. We're going to talk about right triangles at the moment. And hypotenuse, the longest side opposite the 90-degree angle. And this is our positioned angle, which will eventually draw triangles and quadrants. And we'll look at this angle, then the opposite side over here, adjacent side here. And I just put a quick 3, 4, 5 triangle on the board, like 1, 2, 3, and so on. So it's pretty accurate. The cosine of the angle, we always talk about sine then cosine. I think we really would be better off talking about cosine than sine, x to y. But cosine, 3 to 5 ratio, sine of an angle, opposite to hypotenuse. And hopefully you've got already a little bit of a some working knowledge before you're probably watching this video. Just another quick comment here. In trig, we're basically looking at, I give you an angle, you give me a ratio, and that language is the sine of an angle is a ratio. If we go ratio to angle, then we're looking at inverse terminology. And so the arc sine or the inverse sine of a ratio gets us an angle. Just want to state that, plant some seeds. I think the distance formula, from one point to one x, which is really placing the coordinate system to another, and you could use a triangular thought process, horizontal, vertical. I think this is a little awkward for students in terms of speeding up calculations. I think you really want to go to the heart of the Pythagorean relationship and actually visualize it. So 9 and 16 add up to 25, 25 minus 16, 9, 25 minus 9, 16. So if we had a missing side length, we could find the square root of each of these areas gives us that distance. So just throwing those few things out at you. All right, back to the 3, 4, 5. So one of the properties of right triangle trig is it doesn't matter the size of the triangle, the size of the triangle. That might be 3/5. That could be 4/5. That could be 1, but the angle didn't change. All right, so those are some highlights I just wanted to quickly get in front of us before we start tackling this. All right, and so in trig, I'm a big fan of drawing things in the unit circle, working with the 30, 60, 90s, and 45s. And so you got your first, second, third, fourth quadrants. And if we draw them in those quadrants, one thing doesn't change. That's the hypotenuse is going to be held to positive value. Okay, it's like the hand of the clock. Right? Ticking around, going around. That's always the same length. Right? So it's going to be positive. All right, so let's have at it. Let's find the sine of 1. Well, gotta know what that represents. Okay, and so if this, if the sine and cosine are divided, you got a division by the hypotenuse, and the size of the triangle doesn't matter, the angle is going to stay the same, then we might as well fix the hypotenuse to be a unit of 1. All right, so there's a radius of 1 right there. Radius, oh, radius. Yes, radian. Got a little bit of a similarity there in terms of how that sounds. I got a feeling that this is connected to that, and indeed it is. Okay, so in a unit circle, we draw 1 radian. 1 radian is 1 radius distance as measured from here. Okay, so we have to get, I got my trusty cord right here in the science cart. So here we go. Look at that. Well, that's 1 radius distance. Well, it's distance from the center of the circle. But we're going to start measuring as a frame of reference here. So there we go. That bends a little bit right about to there. So that's actually 1 radian. 1 radian is that distance right to there, where we could draw a triangle. Boom, right triangle. Okay. And I don't know, that was done maybe a little too quickly. And if the hypotenuse is always going to be 1, then we're really looking for that amount. Okay, we know that amount is 1. We know this is 0. So the question is, where is that? Boom. Where is it? Boom, 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 over there. Oh, well, this is a height of a half. I think I had a height of a half. I should have actually nailed it better. I think it was maybe there. I'm not sure, but I should go back to Desmos and make sure that's, I should have put a little mark there. All right, so we can estimate that. We can estimate this. Right, and I did. Of course, I cheated. I took a little poetic license. I actually have got a lot of practice with that, right? So, cut to the chase. Circumference equals 2 pi r, right? And if our radius is 1, then the circumference of this is 2 pi, or 6.28 units around the circle. If I go around the circle, I think I just went 360 degrees. So you're familiar with degrees. Less familiar with this concept of using a circle. So I could do that here. I can make a smaller circle. Right? And pretend that that was 1 unit. Right? Then it's 6.28 units all the way around, and that becomes an arc length. Right? So 6.28, 360 degrees. So how does 1 compare to 360 degrees? Well, you play around with that, it's about 57.3 degrees. And so we have 2 language systems. 2 language systems for measuring angles now at cow level. All right. So where was I? Well, if we're going to talk about how do we quickly measure, say, graphing a sinusoid, and I want to go from one place to some other place, right? Degrees don't work too well. You know, this could be temperatures, right? High temperature in a year, low temperature, mid-range temperature, you know, fall, spring, summer, winter. Yeah, it's pretty hard to talk about converting, when's the hottest temperature in this part of the woods? Maybe middle of June, maybe middle of July. Well, middle of July is, I don't know what day of the year that is, but converting days of the year, let's say the 175th day of a year, well, which one works better in terms of conversion? I think converting one number to another number is what we basically do in math. So radians is a better method of modeling physical phenomena out there. All right, so we want to practice a little bit, getting used to, well, what's pi divided by 3? Pi divided by 3 is about 1.04-ish, right? And that number, we don't work with as much historically because, didn't have calculators and computers way back when. So I think the language of trig, introduction to the unit circle, we always have a pi there, right? And I'm not sure that helps to get a sense of 1 radian is this distance. 1 radian is that arc length distance. And therefore, what is the opposite to hypotenuse ratio for the sine function? Well, this, from those of you who have been working with that, you got your √3/2, which is approximately 0.87. So then 1 is a little bit less than that, right? And I'm assuming that you've done some work with trig if you're watching this right now. Doesn't matter whether you have or not. I mean, a radian concept is devoid of this topic. It's really talking about where is our triangle going to be drawn. Right? So I guessed 0.84, and I guess it was 0.8414. I knew I was smaller than, the 60-degree angle. The 60-degree angle would have been a little bit higher. So I was just coming down a little bit. And that was how I kind of figured that one out. I got to get an eraser here. So you have at it. What do you think the sine of 2 is? Where is 2 radians going to take you? Well, you certainly know over here, we'll bring this back just a little bit. Over here is 180 degrees, or pi radians, 3.14. So I cut that in half to get radian distance of 1.57. And where is 2? Well, 2 is 0.43 more. So I'm saying 2's maybe here. All right, and I'm looking at that compared to that. I'm saying, well, it's bigger. It's bigger. So I just threw a 0.9 out. I said, okay, that's about 0.9 to 1. That was my guess. Turns out it was 0.909. 0.909. More accuracy. And that's where the sine of 2 was. How about the sine of 3? Got a feeling if you pause the video, you can probably figure that one out pretty well yourself. So 3 radians is somewhere in here. Right? So somewhere in here is 3 radians. And I purposely put a little space between the arc length and the height of that altitude. So that's 3. Well, the arc length to pi is increasing by 0.14, and this is almost identical to it in size right there. They're almost the same. Now, the circumference arc is increasing, and as I increase to this value, this is actually decreasing. That's actually decreasing, which means that our ratio to arc length measurement, it's almost -1 to 1. So I just decided to put 1 period of the sine function up here quickly so that it plants some seeds here, right? I mean, you're studying this, you're a year or 2 away from calculus, which is all about rates and amounts generated as those rates accumulate, differentiation and integration. I think some seeds need to be planted. I think you need to start thinking about these things before you get to that level. I mean, a lot of people can get through math mechanically, but then have to stop because the conceptualization of what's going on doesn't support the mechanics of taking a test. We want to get some conceptual understanding. So we want to talk about these things before you get to that calculus class. All right, start thinking about, that this is getting smaller, the opposite side length of this. Remember, the hypotenuse is still 1. Right, so does it look like this could be around 1.14? I think so. Turns out it's, I thought it would be actually 0.1395-ish, but it was actually 0.414. Where is it over there? I can see 0.1411, I think is what it was. The actual height, 11, right? And I forgot, 3.14. The next 2 decimal places 1.5. So it's not coming down much. Should have had a better guess here than what I really thought. Right? But if you look at the derivative of the sine function, cosine function, cosine pi, -1. That's the width of pi. All right, so just planting a few seeds. All right, so the sine of 4 got to be a little harder for me. So where's 4? 4 units. This is 3.14, I think 1.57. And I did it over there somewhere. What was this number? I think it was, as a radian length, I think it was 4.71, what that was. And so where's 4? Comparison. That's about halfway, huh? About halfway, somewhere in here. Again, I'm not spending an awful lot of time looking at this, but well, we might as well know that 57.3 is 1 radian, roughly, approximately. So 0.14 to 4 is, brain's slowing down here, 0.86. 0.86 radians is more than halfway. So we're more than halfway, right? But I'm trying to get some ideas here without a calculator, right? Just to get a feel for numbers here. So I think I might even be a little further down. My guess was negative 0.72. That was my guess, random guess. I think I was over here saying, okay, what is that? -5, less than halfway. Negative 0.72 was my guess. If I draw the triangle, I guess I should draw the triangle here. Okay, so it was somewhere in here, right? And I say negative 0.72, rough guess. Turns out it was negative 0.75. So a little lower than what my brain was saying it was. Right? Then sine of 6, well, that's a piece of cake because 2 pi is 6.28. So 6 radius lengths, arc length. Yeah, I figured it was somewhere in here. And again, boy, rotator cuff. Okay. And it's a little higher up than what I just drew. We're getting to that 1-to-1 kind of situation again. And, this is getting longer and this is getting bigger. I mean, I know it's a shorter magnitude, but on a number line, it's getting bigger. So, you're talking at the end here, you're talking positive 1-to-1. There's a 1-to-1 correlation as you zoom in on this instance. All right, so I guessed 0.28 real quick. I think, I said minus 0.275 because it's got to be a little smaller. It turns out it was minus, this altitude was negative 0.279 according to Google. Okay, but goal here was to get an idea of what a radian is because radians are going to be used as angles because they're better at modeling things out in the real world. Radian is just unwrapping. Taking this, I got this long cord. I didn't intend to have this here, but somebody left it. I'll use it. It's in the cord. So, if I were to start somewhere, let's start with this and wrap it around. Wrap it around. And if I unwrap it, well, it matches up with the x-axis so nicely that when we're doing trig in radian measurement, the x-axis, radian. It's radian, the same thing. So instead of calling it the x-axis, why don't we call it the radian axis? The circumference of the circle. And we keep wrapping as many times as we want. Push our number line out as far as we want, and we can think backwards. Unwrap backwards. So we can deal with some negative numbers. All right, I'm on a rant here. Obviously, need another cup of coffee. Been up since 5. I don't know the clock now. All right, so that is just to start the conversation about radians. And you're going to have to think about it. Yeah, you're going to have to not only repeat mechanical, let's do, triangle after triangle. What are we doing as we do it? That's where the language of mathematics is a little different than, parlez-vous français. Okay, I don't have to think about that one too much, though I haven't done any French since I was in 7th or 8th grade. So, but this requires, what's a radian? Okay, that's where math's a little different. You got to be patient, you got to reflect, and you got to allow your neurons to connect. All right, done ranting. Let's post this video anyway because it's a conversation we got to start.